Hey guys, a really quick video about tonicity. It's a little bit of a follow-up of osmosis. So tonicity is just a way to describe what will happen by osmosis. And so the three terms are hypo, iso, and hypertonic. Think of hypo as low, iso as equal, and hyper as plus. So you can think of that easily. Hypoderm, it's under the derm. You can just think of hypo as opposed to hyper. Hyper being a lot, like you hyper, you always like energetic, right? Iso, think about isomers as isotopes. Isomers being different molecules with the same atoms with different conformation. Isotopes being the same atom element but with different neutrons number. Remember, carbon 12, 13, 14, but it's the same, right? Carbon. So that's how you remember iso. And tonic, the tonic being like, we all know the tonic drink, right? But it's really what it means, it's that liquid. So now, if you think of a cell, because all of those things are just great, but compared to what? Less plus my equal. The in and the out of the cell here, you always think of hyper, hypo, and iso as for the point of view of the outside of the cell. Look at the definition in the glossary that we have on Blackboard, but really think about it from the point of view of the outside, right? So if you think of hypo, so when we define hypo, if we say hypotonic for that cell, we would say this cell is in a hypotonic solution. See, in a hypotonic solution, which means the outside of the cell is hypotonic, which means hypo less, so it has less solute than the inside of the cell. So if it has less solute than the inside of the cell, we are in a situation in which our solute, and I will use that color here, our solute concentration, X, from the outside, is smaller than the solute concentration, X, on the inside of the cell, right? That's all it means. Hypo, smaller than the inside, right? And in that case, the solute is once again not able to cross the membrane. So what's going to happen in case of hypotonic, which means that there's less solute outside than inside, we will have solvent rushing inside the cell, the solvent being water in this case. So water, H2O, will rush inside the cell, down its concentration gradient. For those of you who like to think this way, or simply against the concentration gradient of the solute. And that's what the cell will swell, right? Now, if you think of, if you are told that you are the cell, your cell is in a hypertonic, which means that hyper, the outside, is highly concentrated in hex solute compared to the inside. In that case, by osmosis, because X cannot go across the membrane, by osmosis, cell will send water outside of the cell against the concentration gradient of the solute, or down its concentration gradient, because there is a lot more H2O inside than outside, simply due to the amount of solute differential between inside and outside. And so the water will rush out in an effort to dilute X outside. And so your cell will shrink. So hyper means, from the point of view of the cell, that what is the concentration of solute outside of it. So really, when you hear hypertonic, you want to think your cell is going to shrink. If you hear hypotonic, your cell is going to swell. If you think of isotonic, nothing's going to happen, but nothing's going to happen for the cell size, but water still goes across the membrane. If the X concentration is the same, as it is the case in isotonic, inside and outside, water still moves across the membrane. Semi-permeable, water moves freely, it just moves equally in and out. Movement is always there of water, of a solvent. So here it is for this quick video. You guys take care, I'll see you next week.